Welcome to Place Academy. My name is Simutekaarnold. Today we'll be looking at matrix. Under matrix, you'll be looking at how to find the unknown value of the matrix using the determinant. How to find the unknown value of the matrix using the determinant. For example, we are saying we can use the determinant of a matrix to find an unknown value in the matrix. To find the unknown value in the matrix. Okay, so we can use the determinant to find unknown value. We have the value of the determinant of the matrix, the value of the determinant of the matrix. So you open bracket, you write of the matrix K minus 1, then we have negative 2, and then we have 3, we have 3 and K. Okay, so this matrix is a 2 by 2 matrix, 2 by 2 matrix. That's the order of this matrix. So now from this one, we are saying the determinant is equal to 12. So this is the determinant. How do we find the determinant? It is by crossing multiplication. For example, we have this is the major diagonal, and then the minor diagonal we have this is the minor diagonal. Okay, that is the minor diagonal. So let's proceed now. That is the minor diagonal. So from there now we'll have will be K minus 1 multiplied by or we will not use that sign. So K multiplied by K, you open bracket and then you close, minus, you open bracket, we have that is negative 2 multiplied by 3, you close bracket, is equal to 12. So 12 is the determinant of this matrix. So for us to find the value of K, now multiply. K multiplied by K, you get K squared. Negative 1 multiplied by K, you get negative K. So negative multiplied by negative is positive. So 2 times 3, you get 6, is equal to 12. Therefore, when we collect the like terms, we will remain in the form of, will remain in this way, or remain with the quadratic equation. Okay, this is the quadratic equation. Now let's see, equate 12 to the other side of the equation. So we get K squared minus K minus 6 is equal to 0. Okay, is equal to 0. So now this is the quadratic equation. Now how do we factorize the quadratic equation? The way we can factorize the quadratic equation is by finding the factors of which when we add them we'll get negative k. When we add these factors we'll get negative k. When we add the factors we'll get negative k. When we multiply the factors we'll get 6. What are those factors? For example, the factors that I'm thinking about is we have negative 3 and 2. So that when we add them, negative 3 plus 2 will get negative 1, which is the coefficient of negative k. And then when we multiply 2 multiplied by negative 3, we get negative 6. Okay, so these are the factors 2 and 3, 2 and 3. So the sum is negative 1. Okay, so let's proceed. Now we have k squared minus, or we say plus 2, plus 2k minus 3k minus 6. Sorry, so let me just write it down here. So say say k squared minus plus 2k minus 3k minus 6 is equal to 0. Is equal to 0. So therefore, we have negative k squared plus 2k. We group them. K squared plus 2k minus 3k minus 6 is equal to 0. Let's factorize it. Let's find the factors. We find the factors of and those the factors of k. Those will be called the values of k, the possible values of k. Since they are saying find the possible values of k, find the possible values of k, find the possible values of k. So we have k squared plus 2k. Now, what is common here? What is common? It is k. The common factor in k squared plus 2k is k. So you write k, then you open bracket. K into k squared, you remain with k. Plus k into 2k, you remain with 2. You close bracket minus. What is common here? It's negative 3. So you write negative 3, you open bracket. Negative 3 into 3k, into negative 3k, you remain with the k. Negative 3 into negative 6, you remain with the positive 2 is equal to 0. Okay, so therefore we have that. So which is let's group them. So we have k plus 2 and k minus 3 is equal to 0. So therefore the possible values of k, the possible values of k is equal to negative 2 or k is equal to positive 3. Okay, so therefore let's do this. Therefore we have the possible values of k is equal to negative 2 or 3. So these are the possible values of k, possible values